All right, class.
Yes.
Okay, not bad. So right here, there is some issues on your notes. When I printed off your notes, I didn't clear off all the PowerPoints. So yours actually has something over here, right? On part B. Does it have something right there? Yeah. Okay, so I covered it up so I could show you the steps to go there. So we're going to start off with A. So on part A, for this one, we need to look at the reference sheet to see what formula does that go with. So if you have your reference sheet out, that's helpful. And I will, for the sake of the video, I'm going to go all the way back to the beginning of the notes so you can see this. So cosine squared minus sine squared. There we go. And so cosine squared minus sine squared, right? That's what we're looking for. And we're trying to find that. So that's this one right here. Cosine squared minus sine squared. But the A value is different here. So what we're going to do is we're going to take all of this right here and we're going to substitute it for what's on this side. So cosine squared minus sine squared. So this is going to give me cosine of 2, and from my notes it was 2a, right? And so this is the value that I have for my a. Or if you have the reference sheet, I believe it's t's. Is it t's on the reference sheet? Or in the notes it is a's, it is thetas, it's x's. It's whatever that angle is right there. Whatever this angle is. And that's what we're going to be using to replace. So as I do this, it's going to be 2 times, and this is 7x, right? 2 times 7x. All I did is I took my formula, my whole thing of sine squared, or cosine squared minus sine squared, and I'm turning it into the other side. So I'm replacing all of this with just this. And we need to do a little bit of math. What's 2 times 7? 14. So my answer is going to be just cosine of 14x. That's it.
Are you sure?
Wait, hold on. Let me double check. Oh, that must be it. It's circled. Yeah, it's got to be it there.
You never know with you though.
Yes. Yeah, the 2 times the 7 is going to give me the 14. Because it's 2 times whatever my a value was.
No, yeah, but I'm saying like once you multiply the 2 and 7, the parentheses still need to be there?
It's the part of the cosine. Just part of the cosine. It's just whatever angle that is. Does that make sense? Hopefully? Any questions there? No? No questions? All right, the next one is kind of wonky. So that's why I don't want to do what they did. So what I'm going to do is I'm going to go and find, so sine 15, cosine 15. If you want to. Okay, so that's what we're using there. That's what we're starting from. Now, same thing we did on the previous, and not play with our cell phone during a lesson, okay, is we go and look at my reference sheet. We go and look at my reference sheet. There's only one of the identities that has a sine times cosine. There's only one of the identities that has sine times cosine. But it looks slightly different, so I need to fix it. Right? This is the only one that has a sine times cosine, doesn't it? So I'm going to use that one. So I'm going to have to do some manipulating to make this one work. There we go. So I'm going to write my identity out. So it's going to say sine of 2x or theta or beta or gamma or blah t, right, is equal to 2 sine x cosine x, right?
Yeah.
I don't like that C. I don't. There we go. Okay. That's the formula from the reference sheet. Yes?
Yes.
But still, it almost matches what I have. But what's there that I don't want?
The 2.
The 2, very good. So the 2, I don't like that 2. We do not like it here or there because guess what? I don't have a 2 there. So to make this formula match that, what is the 2 doing to my sine cosine? Multiply. So to undo a multiply? So we're dividing both sides of the equation by
2.
by 2. Just like that. Now what's going to happen to the 2's on the right side?
Cancel.
It's going to cancel it out. And so over here on the left-hand side, isn't this sine divided by 2? But can I write that 2 as a fraction? So yeah. Okay, isn't that 2 over 1?
Yeah.
And what I'm going to do here is I'm going to fix that because that is a fraction over fraction, right? Of a fraction over fraction, so I need to multiply by the reciprocal of the bottom. So the reciprocal of the bottom. So the 2 over 1 turns into 1/2. Very good. So it's 1/2 times sine of 2x. So if you have that thing on your notes, I believe it already said that, right? So 1/2 sine of 2x is equal to my sine of x times cosine of x. Now, does this formula here now match what was given to me in the first place? Yes. So now since it matches, what's my x value going to be here? 15, right? So it's going to be 15. So now let's rewrite it. So every place that there's an x now, I'm going to put what?
15.
15. So let's plug it back in. So it's going to be sine of 15 cosine of 15 is equal to 1/2 times sine of 2 times 15. So now I'm trying to get rid of the sine 15 cosine 15, right? So I'm getting rid of all that. I'm only going to work with the left side over here now. Only the left side. So what is 2 times 15? 30, right? So now it's going to say 1/2 times sine of 30. Is 30 a known value? We know 30 degrees. It is on my unit circle. It is a known value. So what is sine at 30? 1/2. So I'm going to bring this down. So it's 1/2 times 1/2, because I brought down my 1/2 that was in front, and sine at 30 is 1/2. Yes? Now I can multiply straight across. So 1 times 1 is 1, and 2 times 2? 4. So my answer is 1/4. Does that make sense? Kinda?
Yeah, wait. So where'd you get the 1/2 from again? The second one?
The second one? Okay, so my unit circle.
Uh-huh.
So you got your unit circle, right? Now go find 30.
Mm-hmm.
And
Oh.
sine value is,
1/2.
so the y value there is 1.
Okay.
There we go.
Thank you.
And that's it. All right, that's it for this example here. So now going with the notes. Going with the notes. So example, that was example 4, right? All right, so that means these are example 4. So right now in class, I'm going to pause the video, and we're going to start by working on 17, 19, 21, and I believe 23. Yes, those all go with example 4, right? All right. Okay.
Wouldn't be mad if it isn't.
All right, let's try this again. Class.
Yes.
All right, so I know those phones are off and away again. So, example 5. Now, this one is a lot harder than the example 5 that is in on your homework problem.
It says harder.
This is harder than the homework. So it's going to look complicated, but it's not that complicated. I believe yours starts off with this, doesn't it? You don't have this piece over here. I just didn't delete it when I was supposed to.
Yeah.
So what we're going to do is we're going to use the sum rule. So the sum is where I'm adding angles together. So 2x plus 1x is 3x, and that's where we're getting that from. That's where we're getting that from. So I'm going to use my formula for that. So it's going to turn into sine of 2x cosine of x plus, come on, sine of x cosine of 2x. And we're turning everything into sine of x. That means x is a single angle. It's not a double angle, because a double angle would say 2x, wouldn't it? Yes?
Right.
A triple angle would say
3x.
3x. Okay? Process elimination here. Come on now. So, we only want single angles now. We want a single angle of sine. So that means everywhere that there is a cosine, I got to get rid of it. Everywhere that there is a sine of 2x, I also need to get rid of that. So what I'm going to do is, I'm going to do some substitution right here. So I'm going to rewrite it because my penmanship right here, I think my pen's running out of ink. So it's going to be sine of 2x cosine of x plus sine of x and times cosine of 2x. Yes? Okay, so everywhere that there is a 2x, I need to get rid of it. I don't want double angles, only single angles. I don't want cosines either. I only want sines. So first thing I'm going to do, let's color coordinate this. I only have one double identity for sine. I'm going to use that right there. So my double identity for sine, from my reference sheet or my notes, my double identity for my sine is going to turn this into 2 sine x cosine x. Right? Yes? That's this. That's just this. Yes? No? Maybe? Times. Bring down my cosine. X. So that's this one right there. Bringing it down. My plus. Sine x. But now I have that cosine 2x. But I don't want it, do I? No. I don't want it. But now cosine 2x, I get a choice. There's 3 different ones I could use. There's 3 different ones I could use. So which one do you think I should use for my cosine 2x?
Like what, the formula?
Yeah, which formula should I use? You guys got the different formulas. There's 3 formulas for cosine 2x.
Oh, the second one?
What's the second one say?
Cosine square x minus sine square x.
Okay, cosine square x minus sine square x.
Oh, wait, no.
Why do I not want to use that?
Oh, no, I just guessed.
Nope. What do I only want? I only want
Sine.
Sine.
sines. So do I want cosines?
No.
No.
Okay.
So I need to look at the ones and only use the ones that have
Sine.
only sines. No cosines.
So
Because I only want sines, right?
So the 2 cosine.
Yep.
Squared.
So it's going to be parentheses 1 minus 2 sine squared, and this is x, right? Yes? Does that make sense here? Because all I want is sines. My other identity had a sine squared minus, or I'm sorry, cosine squared minus sine squared, right? I don't want that because that has a cosine and a sine. The other one, the next one says 2 cosine squared minus 1. But that has a cosine. I don't want cosine, do I? That's why I don't use that one. So my last one has sine squared, and that's all I'm looking for. So every place that I have a cosine, I'm going to have to get rid of. Yes, does that make sense or nonsense? Okay, this goes back to 5.2. Remember when we did 5.2, we had a whole bunch of problems that we had to, try to work things out to rearrange with known values. I'm going to multiply this. I'm going to multiply this now. So let's look right here. So when I multiply, I'm multiplying and I'm going to get a 2. I want black. Sine x. Now cosine times cosine is? Cosine squared.
Oh.
So cosine squared x. So when I'm multiplying these together, I get cosine squared x. Bring down a plus. Now this next thing is going to be a distribution. I'm going to distribute. So watch this. So it's a sine x times 1 gives me?
Sine x.
Yes, sine x. And then sine x times negative 2 sine squared. So I have a positive times a negative is?
A negative.
Negative. So I got a negative, and it's a 1 times 2? 2, right? And that's going to become sine cubed. Sine times sine squared is sine cubed. And so it's almost like no matter how many times I tell people to put their phone away, it still doesn't go away.
Wait, how did you get the sine cube?
All right, so see this right here? Sine
Yeah.
times sine squared. So you already have a sine squared times one more sine gives me sine to the third.
I get that, but okay. It wouldn't just be like sine 1. Wait. So that sine x right there means the first one. It means it's sine squared.
This one?
Yeah.
That's just sine by itself.
Yeah.
That's
so
sine to the first power.
Right. Oh, and then you're multiplying it.
Okay, so now watch this, watch. So it's the same as saying, we know sine is y values, right? So we're going to say y times y squared. Same algebra rule applies. If I'm multiplying, what do I do with the powers? I add the exponents. I'm adding the exponents here, right? So that's why it's going to give me y to the third.
Okay.
Does that make better sense? Okay. So yeah, we haven't done it like this very often with just saying sine by itself. We did x, y's, and r's, which was slightly easier, but we can't do that here with double and triple angles. We can't do those. We only can do those with x, y's, and r's. Single angles. Okay? So now, what's the problem I have with this? I have a cosine. I have a cosine squared here, don't I? So, because I don't want to try and cram everything right here, I'm going to move to a new page from right here. Okay? From right here, so I get, it's going to say 2 sine x cosine squared x plus sine x minus 2 sine cubed x, right? Yes? Did I copy it right?
Yeah.
Now, I'm going to go to the side over here, and I'm going to write down the Pythagorean identity, which is sine squared plus cosine squared equals 1. Yes? So my Pythagorean identity I could use all the time. And one of the key things you always want to look at is whenever I have a square, a sine squared or a cosine squared, I can always substitute it out using Pythagorean identity. So if I want cosine by itself, what do I do with the sine? I'm going to subtract it from both sides, right? So I want this, so I'm going to get rid of my sine squared. So minus sine squared from both sides. If you notice now, I'm not putting my angles there because I don't want to confuse you guys. So my identity now is rearranged. So it's going to be cosine squared is equal to 1 minus sine squared. We did a bunch of this all the time when we had x squared is equal to 1 minus y squared, right? But now this is the same thing, but using the actual word of cosine and the actual word of sine. So I'm going to replace cosine squared with 1 minus sine squared. And that's going to clean up everything here. So it's going to say 2 sine x parentheses, because I'm replacing cosine squared with 1 minus sine squared x. And that's going to give me plus sine x minus 2 sine cubed x, right? Do I have any double angles left? Is there any more 2x's or 3x's?
No.
There's no more double angles. Is there any more cosines?
No.
No more cosines. This, at this point, you could be done. You could be done if this is where you got. I would accept this as an answer because you cleaned up everything. I am going to take it a little bit more because it does clean up a little bit more than this when I distribute and combine like terms. So I'll show you what it does. So for me, okay, if this is what you have, it's fine. We have a 2 sine x out front of this. I'm going to distribute that, so it's going to give me 2 sine x. And when I multiply there, that's going to give me minus 2 sine cubed x. Bring down plus sine x minus 2 sine cubed x. Right here and right here. They're the same, aren't they? So I can combine those together. So negative 2 and negative 2 gives me negative 4. And it's getting kind of warm in here, isn't it? Because I'm watching everyone fall asleep. It's not have to do with the math, because the math is like amazing, right? Math is not boring. It's not going to make you fall asleep. So we would have negative 4. So I'm going to bring this down, so it's going to come up with, right here, this and this. So this is 2 sine x, and this is 1 sine x. Right? There's a 1 implied in front of it. So how many sine x's do we have?
3.
So it's going to be a 3 sine x. And we had minus 4 sine cubed x. Again, you could have stopped earlier as soon as the cosines were gone and the double angle and triple angle's gone. All right, I'm gonna go over some of the homework problems right now because I know someone's gonna have some issues. So I'm gonna do the one example that you guys have for this, and if I see a single phone out, I'm gonna stop doing it. So I'm gonna do your number 4. I think it's 49. So, whoa, yeah. All right, make sure you like, share, and subscribe. Hit that notification button and buy stuff from my merch store because it supplies me with new socks.